let's move on to multiplexers and demultiplexers. Ano naman ito? Multiplexers, multiplex means many into one. This selects one binary information from one of the many input channels and will transmit this to a single output line. Yan tawag dito is data selector. Sometimes it's referred to as data selector. Okay, but I personally call it multiplexers. Or pagka sa lingo ng electronics, we simply call it MUX. Multiplexer. Pagka demultiplexer, we call it demux. Ayan. This is a digital multiplexers of 2 raised to n input channels may be controlled by n number of select lines. Okay, so ito yung isang example nito is yung sa production, sa broadcast or sa film or sa broadcasting, sa variety show. If na-try nyo nang makapanood sa live, halimbawa ng TV show, you will notice that there are several cameras, iba-ibang angles, diba? And then lahat yung nakatutok dun sa stage. Actually, there are some that nakatutok sa audience. But what I'm trying to say is that sa TV, on the user end, ang nakita natin is isang video feed lang. Tama? Pero lahat ng camera nakapalibot is working yun lahat. Paisa-isa lang yung lumalabas. Depende sa director kung ano yung ipapalabas niya dun sa main screen. That's how multiplexer works. You can see these input lines as those cameras, and you can see this output as yung itatransmit na, yung nakikita mo na sa TV. And you can call these selector lines as yung control ng director or ng video editing team. Diba? Gusto ko itong camera na to na nakatutok sa host yung lalabas. So, dito ko siya kukontrolin sa selector lines ko para siya yung lalabas. Diba? Tapos nagpalakpakan yung audience. Gusto ko naman itong camera na to na nakatutok sa audience. Okay. So, siya yung lalabas. Nasaan yung control? Nandito sa select lines. Okay, so that's the multiplexer. So, as you can see here, ang nagko-control talaga is yung select inputs natin. Yeah, when we input here, for example, 0, 0, ang i-output niya is yung input sa I0. Yun lang yung makakalabas. So, either yun ay 0 or 1. The rest are don't care values kasi hindi na yun sila makakalabas dito. Kapag 0, 1 naman, iba naman yan. Yung input naman sa channel 1, sa I1, yung lalabas. Since since binary tayo dito, so either 0 or 1, pinapakita niya lang. The rest are don't care values. Paano pag 1, 0 naman? Yung sa kabila naman, yung I2 naman yung magiging output natin. The rest are don't cares. Pag 1, 1, pag 1, 1, ang lalabas is yung I3. The rest are don't care values. This is the multiplexers. Okay, so this is an example of this circuit. You can also, we have discussed this in the previous slide. So as you can see here kasi, halimbawa, 0, 0. Pag 0 yung S1 tsaka yung S0, makikita naman natin to dito eh. Papansin nyo, 0 yung magiging input sa, let's name this 1, 2, 3, 4. 0 yung mapupunta sa 4 tsaka sa 3. Tama? And then yung 0 mapupunta sa 4 tsaka 2. So ano mangyayari nun? Pag nag-add tayo to any 0, automatic ang magiging output ng AND gate ay 0. So by putting 0 sa S1 and S0, we are effectively disabling AND gates 2, 3, and 4. Tama? Pag 0, 1 naman, 0 si S1, So, alam natin, disable na si 3, 4. And then 1C S0. 1 siya, 1. So, pag pumasok dito sa OR gate na to, magiging 0, 0 si 3, tsaka si 1. So, ang disable ay si 1, 3, and 4. Ang gagana naman si 2. E paano pag 1, 0 naman? 1, 0. So, 0 si 4, tsaka 2, disable na yan. Disable din si ito. Kung ito ay 1, 0. So, 1 ito 0. So, disable din si 1. Disable si 4, tsaka si 2. So, ang lalabas ay si 3. Tama? O, paano naman pag 1, 1? 1. So, 1 ito. Meron tong 1. Ito, merong 1. 0. Tama, 1 dito sa OR gate. Then, magiging 0 output niya. 0 ito. 0 ito. So, automatic. Hindi na ito mag-work. Tama? 1 ito. So, dito naman 1 pa rin. So, 0 siya dito. Ito 1. 0 applies sa 3. So, disable yan. 0 apply sa 1. Disable natin naman yan. Si 1, mag-apply sa 2. Kaso may 0 siya kanina. Disable yan. And then 1 apply sa 4. Tama? O, di si I3 ngayon yung lalabas. Pagka naka 1, 1. Ito yun. Okay, so that's how multiplexer works. We can also cascade multiplexers. Baka naman hindi enough for you yung 4-to-1 MUX. Baka kailangan mong mas madami kasi mas medyo malaki-laki yung production mo, di ba? Madami kang camera. Madami kang kailangan i-capture. So yes, you can cascade a multiplexer. Multiplexer normally has an enable input. So this actually controls the operation of the specific multiplexer. So what does this do? Enable simply means it enables the multiplexer. And then pagka naka-0 ito, it will disable that multiplexer. Ganun lang naman yun. This is also known as strobe. Okay, so in here, you will see that we have two multiplexers that are cascaded. So we have 8 inputs. 4 dito sa multiplexer 1, 4 dito sa multiplexer 2. And then, the selector lines are common to each other. Diba? And the enable line is complementing to each other. Bakit? Pag nag-apply ako ng 1 dito, 1 yung mapoprovide ko dito, 0. Ibig sabihin, ang gaganang multiplexer ko would be itong side na to, itong nasa baba. So ito yung mga papalabasin ko, X4, X5, X6, X7, depending sa BC. Ito, kahit anong lagay ko ng BC dito sa, gawin natin itong multiplexer 1 and multiplexer 2. Sa multiplexer 1, kahit anong lagay ko dyan, dahil naka-disable yan, naka-0 yung enable input niya, hindi yan makakalabas. Diba? Kung nandito naman yung gusto kong gamitin, then dapat ito, gagawin kong 0. Para ito is 0, and ito naman is 1. So ito naman yung naka-off, ito naman multiplexer 1 yung naka-on. So ito naman yung mga lalabas. 0, 0, si X0 yung lalabas. 0, 1, si X1 lalabas. 1, 0, si X2 lalabas. Yes, that's how we cascade multiplexer. Kung gusto mo makita sa loob, anong itsura niyan, ganito siya. Sa loob. 1, 2 na multiplexer. Okay? So, this is our multiplexer. Medyo iba lang yung ano niya dito kasi instead of choosing one from the other, as you can see here, the enable is for all. Ayan, no? Naka-common yung enable sa kanila. So, tapos naka-buffer siya. So, kailan ito gagana? Pagka naka-0 yung enable. 0 papasok sa sa NOT gate, magiging 1. Doon lang siya magiging enable. Ito. Ayan. Bakit? Pagka naka-1 ito, 0 yung ilalagay dito sa lahat ng AND gates ng enable input. Therefore, 0 lahat ng output. Diba? So, yun yung ating how we cascade our multiplexers. Okay, so ito, another ng multiplexer. Medyo iba lang yung pagkaka-design niya. Kasi, if S, take note, the selector line here is 1 lang. Diba, naka-common siya sa lahat, no? Tama? So, if S here is 0, ang lalabas ay lahat ng A. Pagka 1 naman, ang lalabas lahat ng B. Kasi, unlike here, you can see here, isa lang yung output natin. Dito, ang ginawa niya is meron siyang madaming outputs. Okay? So, this is also a multiplexer. Multiple output lang siya. Okay, but we can configure this. We can customize this to be parang ganito. So, input lang natin yan sila lahat sa isang OR gate. 8 input na OR gate para isa-isa lang yung lalabas. Okay? So, multiplexer. Implementing a multiplexer. For this Boolean expression, f of ABC, whereas it's the midterms 0, 2, 4, 7, we're going to use a multiplexer. So since that is a 3 variable function, then we can use a 4-to-1 multiplexer. Okay, so sige, let's start. Now, the first part here is to locate saan ba itong midterm 0, 2, 4, and 7. So, our first step will always be to make a truth table. And then, we will list all the possible combinations for our input variables. So, 0, 0, 0, 0, 0, 1, up to 1, 1, 1. Tama? So, that will be labeled midterm 0 up to 7. And then, we're gonna locate the midterm 0, 2, 4, 7 daw. So, ito 0, 2, 4, ayan o, 4, and then 7. 0, 2, 4, 7. And then, we're gonna try to implement this using a multiplexer. There is actually a procedure for this, or minsan, pwede mo ding tingnan na lang yung relationship between the inputs and the output to come up with a circuit. Pero for now, let's try the procedure. First is we're gonna express the function in SOP form. Okay, this is actually already in SOP form. If we still want to express that yung talagang SOP format na sanay tayo, naka-product term siya, then it will be A prime, B prime, C prime, naka-OR sa A prime, B, C prime, naka-OR sa A, B prime, C prime, naka-OR sa A, B, C. So, yan yung ating pinaka-function. And then the next is, we try to assume, or actually, the step would be, we assume that the most significant bit will be included in the input lines. And then the rest of the bits or the variables will be used in our selection lines in order. Okay, so ito, i-assume ko ito, ilalagay ko to sa input. Ito lalagay ko to sa select lines ko. Okay, and then the third step will be the most significant bit will have a complemented and an uncomplemented form. Bakit? Ito na kasi yun, tinitingnan natin to. We would like to represent all of these combinations by using this input, this most significant bit. As you can see here, the upper part is naka-0 yung A. And then the lower part, yung next 4, naka-1 naman yung A. So we will represent this as A prime, and we will represent this as A. After that, we're gonna make a truth table. Yung truth table nito, tingnan nyo po importante to. So we will represent the input lines I0, I1, I2, and I3. Okay, so lalagay muna natin siya. And then, lalagay natin yung ating most significant bit. Sabi natin, meron tayong uncomplemented and complemented value. So bear with me dito sa bagong mapping na ginagawa natin. So ilalagay ko dito is the uncomplemented value, and here is our this is the complemented and the uncomplemented value. As you can see, for the complemented value, this contains the minterms 0, 1, 2, and 3. And for the uncomplemented value, it contains the minterms 4, 5, 6, and 7. Okay? Now, we are going to locate for the ones dito. Mapapansin nyo that yung 1 sa output natin ay nasa minterms 0, 2, 4, and 7. So, lalagay natin yan dito. 0, 1, 2, 3, 4, 5, 6, 7. Yung 0, 1, 2, 3 nandito sa complemented. 4, 5, 6, 7 nasa uncomplemented form. And then we're gonna titingnan natin alin yung mga minterms na nagamit natin. Sabi ay 0, 2, 4, tsaka 7. Now, paano na natin ito gagawin? The next step is that sa last row, sa third row, i-compare natin yung A complement row tsaka yung A row. If 2 minterms of a column is encircled, then we're gonna write 1. If 2 are uncircled, we're gonna write 0. If 1 is circled, isa lang yung circled, then we're gonna write the name of the row where it is located. So that's the rule. For this column, IO column, you will see that both the A complement row and the A row are both encircled. Ibig sabihin, lalagay natin dito ay 1. Now, for column 1, you will see that both rows are not encircled, so we're gonna put 0. For the column of I2, we'll see na-encircle lang natin is itong minterm 2, which is in the A complement row. Then we're gonna write here A complement. And for I3 column, yung 7, yung minterm 7 yung naka-encircle, and that is in the A row. So, lalagay natin is A. Now, eto na yung isusulat natin. I0 is 1, I1 is 0, I2 is A complement, and I3 is A. Okay? And then, anong sabi kanina? The least significant bits will be the select lines in order. So, A yung most significant natin, the next significant bit will be B. So, that will be S1. Tama? And then the least significant bit will be C. So, that will be S0. And then, we want to enable this, hindi naman siya nakakascade, so we're gonna put here 1. So, meron na tayo ngayong implementation of this Boolean expression using a multiplexer. Now, I want to show you if gagana ba itong multiplexer na to. So, let's go to this website, yung logic.ly. Okay, so ito yung ating logic.ly. So this is a free tool that you can find on the internet. You can check this out. So maganda, no? Maganda tong site na to because it gives us a basic simulator for our logic circuits. So naghahanap sana ako dito nung multiplexer, encoder, and demultiplexer, decoder. Wala, hanggang flip-flops lang siya. So, but it's okay. We can just make a multiplexer. So ito yun. Ginawa ko na lang. And then the inputs of the multiplexer, ito, I0, I1, I2, and I3. So this is actually I2. And ito ay I3. Ayan. So, kanina, kung maalala niyo yung truth table natin, ang minterms natin ay nasa 0, 2, 4, tsaka 7. Okay, so, ano ba yung 0? 0, 0, 0. Tama? So, gagawin natin 0 si A, 0 si B, and 0 si C. Ito si A, B, and C. Okay, so itong nasa taas is A complement. Ayan, naglagay lang ako ng K. Then sabi natin kanina, I0 and I1 will have 1 and 0. So pansin nyo, pagka 0, 0, 0, kawan siya. Tama? Paano pag 0, 0, 1? It's not in our minterm, so dapat mag-off to. So 0, 0, 1. Ayan pa siya. How about naman pag 0, 1, 0? That is actually minterm 2. 0, 1, 0. 0, 1, 0. Naka-on siya. Merong output. How about 0, 1, 1? That is M3. So it should turn off. Ayan. Then what's next? 1, 0, 0. How about 1, 0, 0? Ayun. That is minterm 4. Minterm 5. 1, 0, 1 should be off. And then minterm 6 is 1, 1, 0. 1, 1, 0. Off pa rin. And then midterm 7 is 1, 1, 1. It should turn on. So, ayun. Ito siya. So, you can use this website too. It's a free website. But you can buy it if you want. To double check. To check your answers, your circuit, if they will really work. Okay, so let's proceed back. So yun yung ating implementation of multiplexer. Madami pa, ang dami talagang implementation ito or application ito. Actually, yung imagination lang natin how to use this certain circuit will be the limit kung paano natin to i-apply. Okay? Now, let's move on to the multiplexers. The multiplexers, baliktad naman ito. Kanina is many into 1. Ito naman ay 1 into many. This is many po, hindi many. Okay, the multiplexing, this is the process that receives information from one channel and will distribute this to several channels. So kanina, madaming information, isa lang ang makakalabas. Ngayon naman, baliktad. Isa lang ang information, isa lang makaka-receive. Madaming nag-aantay mag-receive. Diba? Madaming output. So for this, this receives information through a single line input and transmit same information over one of 2 raised to n possible output lines. Ano yung n? N is the number of selection lines. Okay, so this is how our demultiplexer looks like. We have one information and we have several output channels. How are we gonna choose kung saan siya lalabas? We have these select lines. Yung select lines yung magdedetermine. If the select lines is 0, 0, 0, and then dito siya mag-output. We can trace that. Kung 0, 0, 0, so mapapansin nyo, 0 ang A, so 0 si 7, 6, 5, 4, and then 0 si, ayan, 3, 2, and then si C, 0 si 1. Ang naka-1 lang talaga is si Y sub 0. Okay, so we can trace this one by one, pero ibibigay ko na sa inyo paano siya i-trace. You can also make this in logic.ly para i-input nyo na lang isa-isa dito yung ating mga selection inputs. And then you will see that dapat ma-follow niya yung truth table. Okay, if hindi niya na-follow yung truth table, then there's something wrong with your circuit. Hindi baliktad hindi yung there's something wrong with the truth table. Baliktad, no? With the logic circuit. Okay, so that's the multiplexer. Isa yung information, tapos saan mo siya i-output. Isa namang dito is example is madami kang monitor. Tapos meron kang isang parang master computer. Gusto mo mag-present. Diba? So meron kang demultiplexer. Saan mo siya papalabasin? Sa monitor sa harap, monitor sa gilid, sa monitor sa likod. Diba? So that's how demultiplexer works. Okay? So ayun. Now let's go back to this, yung design procedure. Paano nga ba ulit nagde-design? We tried this sa ating magnitude comparator. Diba? We designed a magnitude comparator, a 2-bit magnitude comparator. And just to remind you of how it is done, these are the procedures. You can copy this, and as long as you follow this step by step, yung magiging mali sa pinaka-final work natin is very minimal. Actually, supposedly wala yun kasi you followed the design procedure. Okay, so there are 6 steps. First is you have to state the problem. What do we need? Yun naman ang pag-state ng problem. Ito yung inputs and ano yung needs natin. We're gonna identify the variables and output functions. Okay, isang example nito sa bank. Gusto ko yung bank ko, ang magiging output is an alarm. Kunyari ilaw yan, alarm. But we cannot always say that pag yung bank ko nabuksan yung vault, dun siya mag-alarm. Diba? So there are various factors that will cause an alarm. Halimbawa, kapag yung door nagbukas habang nighttime. Bakit? It will indicate an alarm because there's no banking hours during nighttime and then nag-open siya. Now that can be an alarm. So meron ka ng dalawang variable ngayon. Time tapos door. Pagka 0 yung time indicating na off banking hours and then nag-open yung door, alarm. Nagigets? Okay, and then nag-open yung door and then nag-open din yung vault. So you will what do you call this? You will identify the variables and the output functions. After that, we're gonna assign variables. So hindi naman po pwedeng yung yung input natin is isusulat natin pa isa-isa dito. So we can assign variables. Halimbawa, time I will assign that as A, the door I will assign as B, volt I will assign as C, the alarm I will assign as F. After that, I will make a truth table. Since that is a 3 variable, then my truth table will range from 000 to 111. And then, kailan siya mag-a-alarm? O, ilalagay ko na ngayon. Pagka 0 yan lahat, time is 0, door is 0, meaning nakasara, volt is 0, nakasara, wala dapat alarm. Diba? Time is 1, ibig sabihin banking hours, nakabukas yung pinto, nakabukas yung volt, wala din dapat alarm. Diba? Pero kung yung time is, let's say, non-banking hours, nakabukas yung pinto, nakabukas yung volt, kailangan mag-alarm. O, ganun yung pag-i-interpret. Diba? Kaya, off-banking hours, nakasarado yung pinto, pero nakabuka yung volt. So, pwede din mag-alarm yun. Ay, dapat pala dito siya sa taas, 001. Okay, sorry. Anyway, that's how we do the truth table. Okay, so I hope you're getting an idea on how to do this. After that, if you already have a truth table, you can treat it as any other logic circuits. After the truth table, we're gonna obtain the simplified Boolean expression. Now, dito na papasok na yun yung inyong mga techniques. So, kung master in algebra ka, you can do the algebraic method. Now, if you are medyo mas ka dun sa procedural, kahit mahaba, you can do the K-map, Karnaugh method, or tabulation method. Kasi there are different tabulation method. Karnaugh map is just one of them. There's other advanced tabulation method for obtaining the simplified Boolean expression. Pero hindi nyo na kailangan aralin yan. Okay, so K-map, gusto mo, algebraic method, it's up to you. Okay, then after that, nakuha mo na yung expression, the basic, the simplest expression. Now you're gonna translate that, you're gonna convert that into a logic diagram, a circuit diagram, using the logic gates. Okay, now just a reminder, you should always approach your design by considering this. You should have a minimum number of gates, minimum number of outputs, minimum propagation delay, minimum interconnections. The more connections you have, it will cause a delay. The more connections you have, it may cause a cold solder that will affect the logic level of your logic gate. Kasi mag-create din ng resistance yung cold solder. Okay? And you also have to limit yung driving capabilities ng each logic gates. Yung isang logic gate, hindi yan po pwedeng kukonek mo sa 100 logic gate. Take note, ang pinag-uusapan natin sa logic level is the output voltage, but there is also current in that. So, one logic gate cannot drive 100 or 1,000 logic gates connected to its output. There's only a minimum driving capability. Okay, so that is how we design our combinational logic circuit. Okay, so thank you for watching. Again, this is Engineer Royce for Maliza. If you have any question, you can put it in the chat box or you can contact me through my email. And have a good day.